What's up, algebra? Today we are doing 7.4, which is division properties of exponents. Okay, so we've talked a lot about the multiplication properties of exponents with the last couple of lessons. Today we're looking at division properties. Okay, so it's going to be pretty much the same sort of stuff, but now we're looking at division instead of multiplication. Okay, this starts on page 439 of your book, or in your book if you're following along there. So we're just going to go ahead and look at this one right off the bat to start out. Okay, so this is just an example of how the division property works. We have 4 times 4 times 4 times 4 times 4 for 4 to the 5th. And for 4 to the 3rd, we've got 4 times 4 times 4. Okay, now we know that these two 4s will cancel out and give us 1, so we can cancel them. Okay, same thing with these ones, same things with these ones. Okay, so now we're just left with 4 squared. Okay, this works just like multiplication. With multiplication, we could, as a shortcut, add the exponents. Okay, this time with division, we can just subtract those exponents. Okay, so that's our trick with division. Instead of adding exponents, now we subtract exponents. All right. Yeah, so we'll go ahead and move on now. Okay, so if we go down to the next page, if we look at problem 1, where it's got us, we'll look at B. So it's got m, to the 2nd power, not the 4th, times n, and I'm struggling there, okay, n to the 4th power over m to the 3rd times n to the 3rd. Nope, m to the 5th. My goodness. I'll get some of these right, don't worry. Okay, and that looked bad too. There we go, that's a little bit better at least. Okay, so same thing. We're going to do m first. Okay, m to the 2 minus 5 is m to the negative 3, which will go up here. And then we have n to the 4 minus 3, which is just n to the 1st, or n. Okay, now we want to get rid of that negative, so in order to do that, we'll use that upstairs, downstairs apartment kind of thing that we talked about. So this is a negative Nancy right here, so we're just going to move it down to the bottom so that we make it a positive Patty. And there we go. That is our final answer for this problem. Okay, so we just want to simplify it as far as we can, just like we've done in the past with multiplication. Okay, so I want you to go ahead on your own and try out got it problems B, C, and D. All right, then after that we'll go ahead and move on. All right, now problem 2. This is again scientific notation, just like we looked at in 7.3 a little bit. I think it was, maybe it was 7.2. I don't remember for sure, but I know we looked at it with multiplication a little bit. So we'll look a little bit into division. Okay, if we have a problem like this, first we want to split them up, right? So we'll do these two together, and then we're going to do these two together. Okay, so when we do this one, we'll divide those. They say we get about 0.252. Okay, and then this is what we were just doing with our exponents, right? We subtract them. 7 minus 5 is 2, so we get times 10 squared, and then we can put that into scientific notation by moving it here, which would make it 2.52 times 10 to the 1st power. Okay, that's scientific notation. If we want standard form, that's what this is. Okay, so yeah, that is what we are looking at right there for scientific notation. So nothing too over the top or too different from what we're seeing with our normal ones. Just remember, when we look at scientific notation, you kind of just want to treat these 10s as if they're variables. So you don't want to actually multiply out those 10s unless you get to the end and it's something easy like 10 to the 1st power, right? That one's, that's not too hard to deal with. But yeah, that's it for scientific notation with division. Okay. Okay, so problem 3, we've got z to the 2/3 power over 5, and all of that raised to the power of 3. Okay, this is kind of, we talked about this in 7.3 with multiplication. Okay, and this is what we do with it when we have division. Okay, so it's pretty similar, right? First, we want to do the outer exponent of 3. So we're going to have z to the 2/3, and then remember, we multiply those exponents together. Okay, so to the 2/3 times 3 over, and then the 5 also gets that exponent, so that'd be 5 to the 3rd. Okay, so really we're just distributing to both the numerator and the denominator with that 3. Okay, so then we've got this. Okay, these 3's are going to cancel. Okay, so now we just have z squared over 5 to the 3rd. We should have memorized by now that 5 cubed is 125. All right. And then actually that's it, right? We don't have to go any further than that. So we just end up with z squared equals 125. All right. So hopefully that one's not too bad. I want you to go ahead and try out Got It problem 3A right here. So do that. Pause the video. Once you've done it, we'll go ahead and move on again. All right, so this next example under problem 3 is also kind of interesting. Okay, they give us a over b to the power of -n. Oh, actually, just kidding. We're not going to do that one. Sorry, I thought that was a different one. I thought it was this one for some reason. Then I looked at the variables I was writing and I realized that wasn't it. So this is the one we're actually going to do on problem 4. Okay, so for problem 4 we have 2x, we've got 2x to the 6th over y to the 4th. Okay, and all of that is in parentheses because it's all raised to the -3rd power. All right, now this is where it's kind of interesting, right? I think these ones are kind of cool because now that negative exponent, basically whenever we have a negative exponent on something like this, all we got to do is flip the whole thing, right? Because that negative exponent is going on the 2, it's going on the x, it's going on the y, right? Which means they're all going to have negative exponents, so they would all have to be flipped. Okay, so I'm just going to rewrite it as y to the 4th over 2x to the 6th to the 3rd power. Okay, from here I just solve similar to what we did on the last problem. So y to the 4th times the 3rd would give us y to the 12th, and then over 2 to the 3rd is 8, and then x to the 3rd times the 6th is going to be x to the 18th. All right, and that should be our final answer for that one. Yep, that's what they got as well. Okay, so yeah, that is it for that problem. Last thing I want you guys to do is go ahead and try out Got It problem 4 on your own. Once you've done that, you are good to go on this lesson. I know it's a little bit shorter of a lesson. The reason is it's very similar, like I said earlier, to the things we did with multiplication with exponents. Okay, now we've just flipped it so that it's division. Okay, so the same rules still apply. The only difference is with division, we subtract the exponents instead of add them. If we raise an exponent to another exponent, we are dividing instead of multiplying in certain areas. Okay, but yeah, that is it for this video, and I will see you guys next time in class. Yeah, in class.